Hello everyone, here's another Physics 30 example from Unit 6 on nuclear theory, and this is lesson 3, half-life. So here's our example. We have a total time, 116 seconds, that is required for a radioisotope activity to decrease from 1500 becquerels to 93.75 becquerels. What we need to do is determine its actual half-life. So let's start just piecing together what we know and what we're trying to find out. So first of all, we know the activity rate initially. So that would be the original n value. And this, in half-life, of course, this could be an amount, a rate, a percentage, whatever. In this case, it's an activity rate. So our original activity rate is 1500 becquerels. The new activity rate, what it gets to, is 93.75 becquerels, and the total time elapsed is 116 seconds. So this is the time that has elapsed, 116 seconds. Okay, so from our data sheets and our formulas, when we looked at half-life, we know that we have an equation, which is n is equal to NO, or N naught, and then the 0.5 to the power n, and the n value, the exponent n, is the time that has elapsed over the time for a half-life. And the n is going to be the number of half-lives. Okay, half-lives, period, plural. Okay, so a couple of ways to approach this. We can do just the check, guess and check technique, which in Physics 30 should be sufficient for almost all the questions, I think. I'm pretty sure you don't need, or in fact I know you do not need to have to know how to do logarithms, but I recommend getting used to doing it. It's more of an algebraic, neat, precise way of approaching a question. So let's go ahead and do the guess and check first of all. It's always worth just reminding ourselves what actually is going on with half-lives. So just recall that, of course, with half-lives, we're really just looking at a graph. So if I just quickly sketch a graph here, and I'm not going to put any values on this, I'm just going to rough it in. So here's a graph. Of course, half-life is when it goes from some value, let's just say 100%, so if this is percentage, it goes from 100% and it just drops down in this sort of shape. And at 50%, so when we have 50% of whatever it is that we're looking at, this corresponds to the first half-life. Okay, so this would be, this point here would be the half-life. Okay, this is the T half. Okay, when there's half of it there. Of course, if we kept going, if we then halved it again, we would be down to 25%, and that would correspond to, you guessed it, 2 half-lives, and so on. And so what we can do is we can look at the amounts, because essentially these values here, this 1500 becquerels, this would be basically the original amount. So I could kind of put that here. Let's make it a bit smaller. We could put that here. And the 93, well, that's going to be some value here, and we're not sure. The question is how many divisions of 2 do we have to go down to get to the 93? And that's where we can do our guess and check. So to go from here to here, all I'm going to do is divide by 2. So if I went 1500 divide by 2, I'm going to get a value. Then I'm going to get this value, divide by 2 again, and I'm going to keep doing this. I'm going to keep cycling until I get to the value that I want, which is this 93.75. And if you do that, if you keep going, I think you have to do it. I didn't have the numbers in front of me here. If you do this, I think it's 4 times. Okay, so you have to do this process of dividing by 2 4 times to get to the 93.75 that you want. Okay, so that tells you that there are 4 half-lives that are required to go from here to here. So this is 4 half-lives. Can't write. 4 half-lives. Okay, in other words, n is 4. And so 4 is equal to the total time taken over the actual half-life. So of course what we can do here is to figure out the half-life time. We're just going to go 116 seconds, that's the time, divided by the number of half-lives, which is 4. And that gives us the solution, which is 29 seconds. In other words, a half-life is 29 seconds. And to go from the original activity amount to the new activity amount, you need to have 4 half-lives that have passed, and that's equivalent to the 116 seconds. Okay, that's a guess and check way of doing it, and for physics study, perfect. If you want to know a little bit more for the IB guys, you're going to want to do your logarithm stuff. So here's how we would do that. Okay, so the log method. The aim of the log method is to bring down the exponent, because we have a kind of complicated exponent in that it's a fraction. So if we can bring it down into the normal level on our algebra, then we can expand it and we can solve for whichever part we want to solve. So to do that, we're going to use we're going to recognize that the n can be used in a logarithmic way, and so we're just going to bring the logarithm down. First of all, I'm going to just rearrange it to give me n over no is equal to 0.5 n, and that way it's a nice simple, I can bring this n exponent down nice and easily in front of my 0.5. So if I do that, remember with any math equation, you can do whatever you want to it as long as you do the same to both sides. And so essentially, I guess simplistically, the logarithm method means that if you just apply log to everything, then it essentially brings this exponent down to a normal function. What does that look like? Well, it means that I'm going to put this in brackets. I'm going to log this part, so n over no. So log of that is going to be equal to the log of 0.5. Let's keep that there for a second. And now the exponent comes down multiplied by n. I guess I should put that in brackets as well. Okay, so we can simplify that further, just expand it out. So we'll just say log of, well, the n is 1500 over 93.75, and that's equal to log, let's put it in brackets, 0.5. And then the n, well, the n is time, let's put this in brackets, time over t half, and time is 116, so I can put that in. Time is 116 seconds. So we'll keep going. 1500 divided by 93.75 is 0.0625 divided by, and that's going to be the log of that, so log of that divided by the log of 0.5. Let's put these in brackets. There we go. That's going to be equal to 116 over t half. And so really now it's just a case of plugging all this into your calculator. And when you do that, you get t half to be, surprise, surprise, well, actually it ends up being 28.99 recurring, which is 29 seconds. And that indeed matches our guess and check method that we did previously. Yay.